Hi, I'm Seth, and I study the Higgs boson when it decays into two photons. When the Higgs boson decays into two photons, we measure these photons in the CMS electromagnetic calorimeter. This calorimeter is a grid of lead tungstate crystals that measure the pattern of energy when a photon interacts with matter. The calorimeter lets us measure the photon energy very precisely. Using the energies of the two photons, we can measure the mass of the Higgs boson candidate. A big part of the Higgs to diphoton analysis is figuring out which collision events have the best photon energy measurements so that in turn we have the best possible Higgs mass measurements. Only a small fraction of the Higgs bosons produced at the LHC decay into two photons, about 1 in 4 or 500. This decay is rare because the Higgs can't interact directly with two photons, because the photon is massless. However, this decay can still happen because of an exchange of intermediate particles. This intermediate particle exchange looks a lot like the exchange involved in the production of the Higgs boson from two gluons. Because the CMS electromagnetic calorimeter can measure photons so precisely, the Higgs to diphoton analysis was a major contributor to the 2012 Higgs discovery. By now, we have enough events to easily discover the Higgs all by ourselves without the other channels, and we're a major contributor to the mass measurement. We can also measure the properties of the Higgs, including the spin and the particles it's produced with. So far, what we see is consistent with the standard model, but one day soon, the pattern of collisions we see may point our way to new discoveries.